Okay, let's take a look. So solving the equation. This is a pretty simple one. What are you going to do? Let's just start off with maybe some specifics, and then we'll more importantly talk about how we get to steps. Okay, so you could distribute the 7, right? That's what probably your intuition's telling you to do is distribute the 7, and then you're probably gonna maybe combine some terms and things, right? Okay. How do we know though? This is a pretty easy one, but throughout the year we're gonna get harder and harder examples of algebra problems that we want to solve. When we're solving for something, let's remind ourselves what that's all about. When we solve an equation, we're trying the solution. The solution of an equation is, or R, that means we're going to find the values of the variables that do what?
Make the statement true.
Okay, good. So that's our goal, right? We're trying to find the values. What's our answer going to look like? I don't need any specific answer, but x equals just some number, and we'll know that we're right if we plug that back in and it makes the equation work, correct? So our goal here is always to find the values of the variables that satisfy the equation. And make it true, okay? So what we want to do today is I want to try to help you organize your thinking about this stuff so you know how to do what first. You know, what do you do and in what order? Not surprisingly, if we're talking about order of the things that we're going to do or the operations we're going to do, we're going to use our PEMDAS tree. But we got to be very particular about this. So when we're solving an equation, our goal is always going to be to get an x by itself in this case. We want to isolate the variable. Solving means isolate. How come I can't isolate x right now, though? What's the problem? It's on both sides. We have multiple instances of the x. It shows up in multiple places, right? So our goal is to get it to where there's a single x. And I'm going to say this about 1 billion times. If I can point to a single variable on the board in an equation, I can isolate it, right? So that's always our goal is first we got to get it down to a place where we have a single variable we can point to so we can isolate it. Then we isolate it. So to get this down to a single x, that means we have to simplify things, right? It's too complicated. We want to bring things together and simplify stuff. So we're always going to start off by going in the traditional simplified direction. So regular order of operations until we get a single x, and once we get that single x, then we're going to flip it around and we're going to reverse the operations to get the x by itself. It's a really simple rule, but that just knowing that takes care of over half of what we've learned this year. You just learn that stuff well. That accounts for an awful lot in Algebra 2. So the bottoms-up method is going to be to solve or isolate. They mean the same thing. Okay, so step 1. Let's do the orange steps first, the simplify steps. Is there anything in parentheses we can do to simplify? Inside the parentheses? No, we can't. The terms don't add up. Any exponents? No. Multiplication? Ah, there's where we distribute the 7, right? We have to distribute the 7 to both parts, and that gives us what? Good. 7x minus 42 equals 10x minus 78. I still have multiple versions of x there, but what can I do now? Oh, good. I can subtract x's from one side to the other side. When we talk about equations, I like to kind of think about this almost sort of visually. We want to think about if we've got this equation and the equal sign is in the middle, I've got these two sides of the equation. We're going to think about pushing stuff from one side to the other. In this case, where do I want to push the x's, to the left or the right? It'll work either way, but there's one slightly better answer here.
Is it just whatever's easier, or
Yeah, well, what's going to make it easier, exactly?
Oh, 7 minus, that's 10 minus 7, so you don't
Okay, we want to push them to the right, so we'll end up with a positive number of x's, right? It just makes things a little bit easier in the future. So we'll subtract 7x, we get down to the, we can skip, well, we did the multiply step. Now we're down to the add subtract step. Subtract 7x from both sides. And those go away. Here I'm going to get what? 3x. Okay, now at last, look what we've got. Now I've got a single x that I can point to, and so now I have to go about the job of isolating it. So that means we're going to work bottom up on the other side. So in other words, I want to do all the steps I need to get the x by itself, starting off with it adding and subtracting. If I'm trying to isolate a variable, think about this just visually. Think about this like a cartoon. I'm going to do all these things, but at the end I'm going to have an x on the right side of this equation by itself, correct? So I want to just get everything else to the other side of the equation. What's the add or subtract step that I need to do first then?
Add 78.
Add 78. There you go. So those go away. I'm just left with a 3x equals, what is that, 36? So last step then, divide. So we did the add step, and now we got the divide step. Divide each side by 3, and we got it. X is by itself. So our final answer is x equals 12. And on a test, you'd be crazy not to do what? Check it. Why would you ever enter that like on Moodle on a test without checking it first? Because if it's wrong on a test, you're not going to get to just open it up for full credit, right? Always check that stuff. I'll show you a little trick. Quickly, a little trick here for doing this with the graphing calculators. Okay, if the value I'm checking is, was it 12? Is that right? If the value I'm checking is 12, do this. Store that as x. So I'll type in the number 12, and then I'm going to hit the store. STO is store. I'm going to store that as x. And then I have to hit enter. Okay? Now all I got to do is I can type in that left expression with an x in there and hit enter. So 7 times the quantity x minus 6. And if I hit enter, what's significant about that? 42 is important. How come? It should equal the other side. That's the value that the left side gives me when I plug in x equals 12, right? I can do the same thing to the right side. So I'll do 10x minus 78 and hit enter, and I know I got it right because both sides give me the same value when x is equal to 12. Okay? Pretty handy. Easy way to check it. Okay. What about something like this? Let's just get a little bit harder with these things. What if we've got one like this? What's different about this and what immediately makes it look a little harder? Fractions. And they do. They make it a little bit harder if there's fractions in it, but not that much. So what are our options here? We could do the same kind of stuff we did last time. We could just follow our order of operations and combine like terms, but the problem is going to be, I'm not going to do this, but you can all relate to this. The problem is going to be that I'm going to have to be adding and subtracting and dividing and multiplying all these fractions the whole time, right? We'd rather avoid that, okay? So how could we? How could we get rid of the fractions completely? What can we do? Okay, we could write the 7 as a 7 over 1 and the 3 as a 3 over 1. And then we got everything as fractions. But my goal here is, can we do something to eliminate the fractions so this becomes a problem more like the first one? It's easier to deal with. Okay, I heard reciprocal, I heard some decimals. Those are all reasonable ideas, and we could do some of that stuff maybe on a calculator. But there is a trick that maybe you're not familiar with. It's called clearing the fractions. Okay, this is big. When we're going to clear the fractions, now you got to be careful with this because there's some cases where it works and some cases where you have to be careful with it. If you have an equation where you have nothing being multiplied, right? Where you don't have things in parentheses and stuff being distributed, then in other words, I just have a bunch of separate terms. In this case, how many terms do I have in that entire equation? Terms are the things that are added or subtracted. Right? So how many terms are there up there that are being combined? More than that. 4 total, right? 2 on the left and 2 on the right. How do I know? Well, because these are just things that are only being combined by addition, and it could also be subtraction, right? You got 2 terms on the left and 2 terms on the right. Yes, ma'am?
Why isn't it considered nothing being multiplied when 1 over 6 adds?
Well, okay, so you're right. Inside this, there is I'm multiplying by the variable there. You're right. But what I mean by things being multiplied is stuff like maybe like that, where I've got something outside that's being distributed over a quantity. Okay, that complicates things a little bit. And we'll get to one like that as an example in just a little bit. Okay, but in this case, I've got 4 terms. All I have to do is I'm just going to multiply both sides through. I've got to pick a special number. The number I'm going to pick is going to be the least common multiple of all the denominators. In other words, the smallest number that all of the denominators divide into easily, which is the same thing as the common denominator, right? Least common denominator. So what would that be? The smallest thing what are the 2 denominators? 6 and 3, and then the ones we don't care about, right? They divide into everything. But the 6 and the 3, what's the smallest number that both 6 and 3 divide into? No. 6 doesn't divide into 3. No. You guys are thinking of factors. What's the smallest thing that they both divide into? Now, one way to do this would be to say, we want the least common multiple, right? The smallest common multiple. And so I'm going to do this one time, then you'll get it, and I won't have to do this again. But if I made a list of all the multiples of 6, I think we actually might have done this like a couple weeks ago. I get 6, 12, 18, etc., right? What are the multiples of 3? 3, 6, 9. Well, there it is. 6 is the smallest one that appears on both lists, right? You don't have to go through all that process. A lot of times you can just kind of power through it in your head. You know, what's the smallest thing they both divide into? Well, 3 goes into 6, so it'd be 6, right? 6 divides into itself one time. Okay, make sense? So we're going to multiply each side through by 6. I can write that as 6 over 1 if I want to. I could write the 7 as 7 over 1, that's fine. Don't really have to. What am I going to get then if I distribute? Picking that number was a good choice. If I multiply 6 times 1/6, what do I get? 1. Yeah, so they cancel, and that first term is just going to be an x. 6 times 7, I heard it, 42. 6 times 1/3, 2, right? That'd be just 6 over 3, which would be 2. So I'm going to get a 2x on that side, and then 6 times 3 is 18. Now that's easy, right? That's a piece of cake there. Okay, we traded a problem that looked sort of ugly with all those fractions for a really simple one that's a slam dunk in one step, right? Okay, let's try a little harder version of that. What about something like that right there? Okay, this fits the bill though, doesn't it? We've got 4 terms. Nothing's being multiplied here. We just have a bunch of terms, but we have lots of fractions in there. So once again, we want to try to clear the fractions. First thing is we got to pick the smallest number. And if you don't get the smallest one, it'll still work, but it just makes it hard. You want to get the smallest number that they all divide into, the least common multiple of all the denominators, 8, 5, 4, and 20. So just take a little bit and think about that. Later in the year, we'll come back and we'll review how we can go about finding the least common multiple in a little bit more strategic way. And we do a little harder problems. But for now, I'm not going to worry about it. What is it? What do you think? 40, yeah. 40 is the smallest number they all divide into. Okay, so if we multiply each side through by 40, I want to show you a great trick here. Now, when we multiply fractions, and I could write this as 40 over 1. What's our rule for multiplying fractions? Straight across, right? We multiply straight across. So some of these could be pretty big. Like if I were to multiply, for example, 40 times 17, I'm getting big numbers. I'm getting 680. 680 divided by 20. That's a big fraction. What is that real quick? 680 divided by 20. It's hard. We can't get it immediately, right? It takes a little while. You've got to whittle that one down. That's a lot of extra work. So multiplying first and then reducing involves big numbers. Is there an easier way to do this? What would it be? What's a better strategy? Yeah, we're going to reduce first and then multiply. Now, does that always work in every case with fractions? No, but it always works with clearing the fractions because the number 40, we handpicked that one so that all of the denominators divide evenly into it, right? So everything is going to reduce very nicely here. We can always reduce first and then multiply. Here's how I show this. I put this, well, I'll publish this in the notes, but this is, you might want this in your notes. This is pretty important. So here's how I like to do this. When I distribute the 40 to the first term, what's 40 divided by 8? Let's reduce. 5. So you cancel the bottom and you just multiply that by the top, right? 5 times 5? 25. How easy, right? There's the first term. What's 40 over 5? 8. Cancel the bottom. 8 times 3? 24. Simple, right? Other side. 40 over 4? 10 times 3? 30. And this one that was pretty hard, right? 680 over 20 seems pretty hard. What's 40 over 20? 2 times 17? 34. That's no big deal. Way easier, right? And we don't even have to do that. That's easy from there. Right, I'm just going to, what would the steps be? Well, maybe we'll do this one time. Things we're just getting into this stuff. What am I going to do first here? Yeah, I don't have a single x yet, right? So I got to simplify first. So the only thing I've got to do to simplify is subtract 25x from both sides. What's that, 5x? Okay, and from here on out, I won't even finish, but I'm going to ask you to do this all year. I'm going to sometimes ask you to do, tell me the next 2 steps in order. What are the 2 steps to solve for x in order? What would I do first? Good, I'd have to get, well, I'm going to get x by itself, but if I'm working up from the bottom on order of operations, I've got to add and subtract first. So I got to first subtract 34 away from that side, and then whatever I get, I divide by 5, right? Okay? All right, so let's have a look at something like this. Okay, this one's a little bit trickier. This time, if we try to multiply through, what people tend to do with this, you tell me what's wrong with this. Okay, what's going to be the least common multiple of all those numbers? 40? Do you agree? Okay. So if I multiply 40 through, and this is okay to do, but if I multiply 40 through, that's fine, but do I distribute the 40? How many things are being multiplied on the left side now? 3, exactly. I've got 40 times 1/2 times that whole big quantity, but because it's in grouping symbols, it counts as one thing, right? That makes sense? So there's 3 factors. When I multiply things, I multiply 2 at a time. So on the right side, what would I do first, probably? Or left side, sorry. What am I going to do first? I got to multiply things 2 at a time, right? So how about if we just multiply those 2 together? What do we get? 20. So now I'm going to get 20 times all this stuff. Right? On this side, I don't have to mess with that. I'm just distributing here, right? On the left side, I've only got two things. I'm multiplying the 40 times what used to be the entire, did I say left side? I'm gonna learn my directions there, on the right side. I'm gonna multiply the 40 times all the stuff that used to just be on the right side that's now in brackets. So I'll distribute it. So what's 40 over 10? 4. So 4 times 13, just double it twice, right? If I multiply by 4. 13 doubled is doubled. 52. 40 over 2, 20 times 1. Okay, so right side's taken care of. I just have to do that same thing to the left side now. So 20 over 8, well, look what happened. 20 over 8, see, there's the problem. Now I end up with something that didn't, it didn't work, right? 20 over 8 didn't reduce. Okay, is it a huge issue? Probably not. I mean, we haven't done anything wrong yet, right? I could distribute this, and I'm going to get 20 over 8 reduces to what this time? I'm going to get a 4. What goes into both those? 4 goes into both, right? So I could get a 2 on the bottom and a 5 on the top. Does that make sense? 20 over 8 reduces to 5 over 2. So I get 5 halves x. 20 over 4 is what? 5. So I get minus 15. Well, that's not supposed to be an x, is it? Oh, I guess it can't be. That's fine. Oh well. Okay, so that's the danger of this. If you just try it, it's not a huge danger. What would I do now? What do you think? I don't really want to deal with that fraction, but it's really simple to get rid of. But what would I do this time? Multiply both sides by 2. Sure, that's easy. So 2 over 2 is, they cancel, right? So I'm just going to get 5x, 2 times 5, 10, 2 times 52, 104. Okay, now it's easy. Just combine like terms and isolate x, right? That'd be no big deal. Okay? But what's the moral of the story here? It didn't work like it did on this first one. And this, I don't want to like make too big a deal out of this. But what could we have done that might have been a little bit easier here? Might have saved a step. Instead, we could have just distributed the 1/2 one time and left these things as fractions. No big deal. Just leave them as fractions. And let me show you this. Is that something I can grab? Oh, it's not. Darn it. Somebody write down what that original equation is real quick. I think I've got it. No, I don't. Write that down and I'll have you read it back to me. Original probably started there. Okay? So what do we have? 1/2 times, what was it again? 7/8 x minus 3/4 x equals x. Was it x?
Yeah.
Minus? Okay. So we're not going to try to clear the fractions. We're just going to leave them as ugly fractions the first time. We're going to multiply the 1/2 through, but multiplying fractions is easy. It's adding fractions that's tougher, adding and subtracting. So if I distribute this thing, I'm just going to multiply top and bottom. What is the first, if I distribute, what does the first fraction become then? One times 7 is, 2 times 8 is, so I must get 7/16 x. 1/2 times 3/4, I'm going to get minus 3 over 8, good, x, equals 13/10 x minus 1/2. Now, I won't even finish the problem, but now we've got it down to the point where I've got just 4 separate terms. So now I can figure out a number that I can multiply through that would clear all the fractions. Only issue is it's a little bigger number. what would be the smallest number that goes into all those? 16 doesn't go into 40, right? It does go into 80. Okay, so this time it would just be an 80. 16 times 5, 8 times 10, 10 times 8, 2 times 40. Okay? Makes sense? And that would work. Then it would clear them in one shot. Wouldn't have to do it twice. Okay? Questions? I think that's all I'm going to do today. Yeah, I'll let you work. Grab Chromebooks. Does everybody know how to figure out what's due and when it's due? Okay, work. Any questions answered? I need the yellow sheets if you haven't turned them in.